These examples come from the Difference of Perfect Squares Level 1 section of Delta Math. This was the second kind of factoring that we took a look at and is all about difference, which would mean subtraction. So we need to make sure that we have minus signs in our problem. And we're subtracting perfect squares. So things like 4, 9, 16, 25, things that are perfect squares are where the square roots are whole numbers. So for example, in this problem, if I square root 81, I get 9 because 9 times 9 makes 81. If you square root x squared, the square root and the squared undo each other, and you get x because x times x makes x squared. So these are the two things that we're going to use to build our answer. Our answer is going to be two binomials, kind of like this. The x's go in the front because x squared is in the front. The square root of 81, 9, goes in the back because 81 was in the back. And we make 1 plus and 1 minus. We need one of each because when you do polynomial multiplication, when you use FOIL here, you want to make sure that that middle term, the x term, cancels out. So if you FOIL it, x times x makes x squared. This would make negative 9x plus 9x, which does indeed cancel out, and positive 9 and negative 9 makes 81. So this is our final answer. Delta Math sometimes puts these, I don't know, what you might consider backwards with the constant term in the front and the x squared in the back. But the process is still the same. I would still square root 25 and get 5. I would still square root x squared and just get x. So when I make my answer, 25 was in the front, so the 5s are going to go in the front. We're square rooting each piece. The x is going to go in the back, which is a little different from what we did in class. We have 1 plus and 1 minus. You could have minus and then plus. As long as you have one of each, it's still the same. Occasionally, they'll also put a number in front, a leading coefficient right here, but the process is still the same. I'm going to end up square rooting 25. We'll square root x squared. And we'll also end up square rooting 121, which is going to be 11. So when I go to build my answer, 25 is all the way in the front, so that means 5 is going to go all the way in the front. Connected to 25 is the x squared, so that means x will be connected to 5. And when I square root 121, we'll put the 11 in the back, and we'll still keep the 1 plus 1 minus idea.